techniques at the Woodsmith mine shaft sinking project. The presentation will describe the drill and blast process used and also give an update on lateral blasting that is currently being undertaken. So I'll tell you a bit about Neil. He's worked on the project since January 2021 as a blasting engineer responsible for blast designs, explosive ordering, shot firing and training. Neil has been involved with various drill and blast projects throughout the world since leaving university in 2002. He has experience in quarry blasting, underwater blasting, tunnel blasting, and now shaft blasting. The floor is yours. Thank you.
Thanks very much. Evening, everybody. Thanks for coming. Thanks for Ian Christie for inviting me. I think it'd be a year ago, wouldn't it, when we discussed it, and so since then, actually, since I spoke to Ian, I've done 2 of these, one for the Derbyshire Buxton branch and one for the Yorkshire branch at Wetherby. So when I did the first one at Buxton, we started blasting at Woodsmith, and it was, so there were so many slides. What you're getting now is another, say, 6 months worth of blasting. So there's quite a lot. Yeah, so I'll try and, if it overruns, just let me know, or we can stop it at any point, yeah. Yeah, so I've done sort of 22 years drilling and blasting, mainly just blasting. I don't really go on the drill rigs, obviously, but yeah, underwater blasting with rockfall, quarry blasting with Bam Riches, and now like shaft blasting with Joseph Gallagher's at Woodsmith. So where are some of you will have heard of Woodsmith, some maybe not, I don't know. Where are we? We're down in Whitby. You can see the little blue dot. And what are we doing? So the aim is at a mile down, a vertical mile down, there's a mineral called polyhalite. And they know this from, there's a mine on the just up the road called Bolby Mine. They've tapped into the resource. But the red line on the diagram shows you sort of what they're expecting the resource to look like. It's a fertilizer, basically, and apparently plants need 6 macronutrients to grow. This stuff has got 4 of them already in it. Where is it? Potassium, sulfur, magnesium, and calcium. It's meant to be super good. If you put it on crops, it speeds up the growth and enhances it. There was some pictures on LinkedIn maybe the other month of this pumpkin that was size of probably weighed a ton. So that's what we're trying to get. And when we get there, I like to call it a gold mine. It's almost pure. When we get it out and we mill it down into the little balls, look like ANFO balls, really, don't they? AN balls. You know, there's no waste. It can be sold immediately, like in that form. So it's crushed down, milled into the balls and sold. We're a few years away from that. So obviously this talk is just on what we're doing to get to the mile down. Yeah? Planning permission for the job was given in 2011, and we're now 2024, and we're still on with it. So that's a little bit of a cross section, not to scale. So this area here is Middlesbrough. The far side of the screen is Whitby. That length is sort of, that tunnel there is like 37 kilometres long. So it gives you that sort of perspective. And then there's your mile deep, these 2 white shafts that are going down, and you see the sort of road header at the bottom. So it's not to scale, but it gives you an idea. So if I just crop that diagram up a bit, and then I've took Google Earth and just took a screenshot. So there's Middlesbrough, and Whitby's sort of 3/4 of the way across. So, because the site doesn't just comprise Woodsmith Mine, yeah, there's kind of 4 locations really. So we've got Woodsmith Mine where the shafts are, near Whitby, just up onto the hilltop. We've got an intermediate shaft called Lady Cross, that's in construction at the moment. We've got another intermediate shaft about halfway along the tunnel, Lockwood Beck. And then we've got the materials handling facility. So what links them all is this tunnel. You might have seen again on LinkedIn, Strabag, they're driving this tunnel using Stella Rose. Originally, we were meant to launch 3 TBMs, one from Whitby coming this way, one from Middlesbrough going that way, and then one in the middle from Lockwood Beck. I think I've got the next slide on it, running whichever way it was running. 3 TBMs. Basically, when Sirius Minerals got into difficulty with money, things had to be chopped and changed around. They decided to get rid of the other 2 TBMs, and this TBM will do the full 37-kilometre run. It's now broken some world records for the length of 1 TBM tunnel, I think. And I think, not right, is it right, Charlie? I think we're just near Lady Cross. Yeah, so it's got about, I don't know, 1.5 years to go yet before it actually gets to Woodsmith mine at Whitby. Right, so so the tunnel is going to transport that when we extract that mineral from a mile deep, it's going to go back a slide. It's going to come up the deep shaft and then travel along that tunnel on a conveyor belt, taking all the trucks off the roads. Obviously, in the quarries, we're used to the trucks leaving, all other than Glen Sandy, a place like that. So this takes all the trucks off the road and it goes all the way along the conveyor belt to Middlesbrough. So that's the purpose of the tunnel. So we're underway with that. This one just shows you them 3 TBMs. Right, so it was Lockwood. So one from Middlesbrough to Lockwood, one from Lockwood towards Whitby, and then one from Whitby. And they sort of scrapped them too, yeah. We didn't even get going with them. That's an image off Google taken a while back. It's not really much different to that, to be honest, nowadays. But the tall tower on the left is the shaft that I'm working on. So it's a lot shorter, that shaft. It's not going to be a mile deep. It's only about 350 meters deep. But the 2 buildings, you can see these 2 here. So inside them are the deep shafts going a mile down. Current figures, what we at, Charlie? About 750 meters on one of them.
Yeah, 750 at one and 6 to 8.
Yeah, so we're sort of near enough halfway on one of them. The other one started later, so it's a bit behind. It's a few months behind. But it's the mine of the future. What's it going to look like? That's the sort of, once we've got to the Pelly Halite and we're mining it, that's the image that they want to portray. So all the MTS tower that I work at, that tall one, and any other buildings, anything that's got the wooden clad is staying just over this side here. And that basically like that. Bund it up, get some trees around it, yeah, and hide it from view. So before I talk about the blasting, the 2 deep shafts, a mile deep, how do you get there? Herring Connect invented, designed, made these machines. It's basically like a tunnel boring machine, but vertical, yeah? SBRs, we call them, shaft boring road headers. They've only been used on a job in Belarus and one in Canada, Janssen. I think we've got numbers 5 and 6. There's only been 6 built. They're about 64 meters tall. That's obviously showing you out on surface, but that is sat in the ground now, chewing away at the rock. So it's got a head with the picks on, drum spins, and as it swings forward, it takes out what we call pizza slices, basically. It just keeps cutting the rock, keep going down. So that's the deep shafts. The shaft that's just to the side, this one, this is where they were going to launch one of the TBMs, the one going the other way. Even though it got scrapped, we still need this shaft and the tunnels that are in it for to access all the different levels underground, keep everything below surface. So this is the one that I work at mainly. This one is kind of old school. This is drill and blast, because it's not deep enough to warrant buying an SBR like on the other shafts. Yeah, I mean we're only sinking 350 meters, and the SBR is 64 meters tall. Like it was not worth it. So old ways, Galloway stage. That was it being lifted in, probably, I don't know, 2017 maybe. That's it's lifted in, and then they built that tower on top, yeah. And that's just an image I got off Google. It's quite a good one where it shows these grabs. So where you blast and they grab them up, put it into the buckets. So going into that tall building, we jump into these buckets here, and that's how we ride down to the bottom. That's me heading in, and the Galloway's the thing that's in front of me with the two holes, if you will, the bucket wells. And actually, that's me going in to inspect a blast. We've just blasted, so you can just see the blasted rock through the hole. Yeah, concrete lined, ventilation running down the other side there. We've got air and water pipes. So that Galloway there, the Galloway stage, that can move up and down the shaft, yeah. So it's on the ropes, and we tell the windman to move it up and down. We do so if we're blasting, we'd move it up 30 meters so that we don't damage it. That's me looking back up. So if you look at them two holes, the one on the left, there's a bucket sat there. They're only 1.9 meters diameter. So everything you need to get through has to fit through a 1.9 meter diameter circle, basically. In the bit, when you see some other images of the machinery that we've got down there, like I can't believe how we've squeezed them through the gaps. And that's another image we're looking up. You can see the two grabs. They're locked into the Galloway, and when we need them, we lower them down, and they grab the blasted rock. Yeah, Komatsu VSM's vertical shaft muckers. That's a video on YouTube, an animated video, and that's what they look like. Monstrous things. You don't want to be close to them when they're operating. Nobody's allowed down. Everyone has to stay up on the Galloway stage. Yeah, quite vicious things. So that's the mucking cycle. So just flipping back to the drill and blast bit. Jumbos, we've got two of them, but both of them have got two drills, so we can have four drills going at once. Yeah, these are again monstrous, 14 meters tall. Then it really, the hammers, everything was too overpowered for the mudstone we were in, but it did the job. They'd be good in, they'd be suited for a granite. Like that's kind of like the mudstone we were going through, really. Well, we're still in it now. Just watch your fingers, it does get a bit sharp. When the air gets to this rock, it sort of starts to crumble a bit. There's like bits and pieces falling off all the time. Drill steels were 4.8 meters, T38s, top hammer, button bits. We tried some cross bits, but there's that many people on the drill rigs, you never really got any feedback as to which they preferred. I had some lads, oh, we like the cross bits. Oh, we like the button bits. made no difference to me.
Stroller for you, Neil.
Yeah, just drill slam it in 4.5 meters, and then we'll go and blast it. And then we had the void holes, so we drilled some void holes. I'll show you in a minute, and they're bigger diameter. So we drill the hole with 64 mil top left, and then we ream it out with this bigger 127 mil drill bit, the white one. That's so the jumbos get lowered down the shaft into them bucket wells and get like almost, they seat themselves in them bucket wells, and then they open up and they can drill every which way you want, and there's 4 of them. It's not, you can't see. So the first one's landed there and he's just opened it up ready for drilling. The second one will be coming down on my left hand side, but I have to get out the bucket before it comes, you see. So that's that pattern that I marked out there. You can see these are the void holes, these bigger ones, and they're in the pink, and then the yellow ones are just marked up in yellow. So with underground blasting, you tend to have these, you can't see it on there because of that little screen, but there's like a burn cut, we call it, in the middle, where you've got a high concentration of explosives. That goes first, fires out the rock, and then it gives all the other rock time to move towards the centre and out. And so, like, say on that diagram there, that's obviously a tunnel. The 4 crosses would be the bigger holes. They're left empty, yeah. So basically, with the shaft blasting, we just took that face design and sort of plonked it on the floor. As simple as that. 6 or 8 void holes there in blue, followed by the red ones, high concentration, and then works its way out to the yellows, and then the greens are closely spaced to try and get a bit of a nice edge. So we had void holes 127 mil, cut holes 64 mil, bulk holes 64 mil, perimeter holes 64 mil. And there's other names that you might have heard in the past, like ream, easers, contour. So, yeah. When we started with the Redpath, the Canadian shaft sinkers that are here, that are on the project now, they weren't there at the very start. So when we started, we were just Gallagher's and Anglo-American. And I made this little tool out of a piece of 110 volt cable and a bit of wood. And all I said to the shaft tech was, give me the centre of the shaft. And I used to get someone to just stand on that, and then I'd pull it out and I'd swing the wire around, and when I pulled it onto one of these tape marks, where them little red tags are on it, that's where I spread the dot. So that's me marking it out, and that's like the result. So it was quite good, yeah. Working from the centre, just swinging it around, spraying the dots. The Canadians were like, no, what are you doing? We do it from the edges in. And I'm like, well, it's whatever you want to do, but that's what we're doing at the moment. We're rolling with it, and it was no issues, you know. And then if you look at this one, that is a mega blast we did with 3. You can see 3 burn cuts in it. So that, yeah, I'll show you the drilling on that in a minute. That was the biggest blast we did. It was when we started to widen out, so it was quite complicated to mark it out to get it all. Do you know what I mean? There you go. That's what it looked like on the Shot Plus software. Actually, so in a minute, I'll just. When we widened out, there was 4 big blasts we did. This was the biggest one. That there, after all the years of quarrying, I remember doing some right complicated blast designs at Glen Sander, where it was like 3D modelling over lumps and stitching together surveys and whatever. that's probably the most complicated one I've ever had to do. Because the angle, these were at something like 40 odd 50 degrees. So you know what it's like. The holes at the top are this far apart, but at the bottom, they're now at 1.5 meters apart. It was horrendous to get that running and with the 4 drill rigs going. So explosives, we would bring them down in this kibble bucket. Again, it has to fit through the 1.9 meter hole, so it's a specially made, bucket. Land it on the floor, unhook the rope, and then it's there for us to take the explosives out. All packaged explosives, we didn't use pumped emulsion. There was talks of it a while back, we never got it off the ground, yeah. We're talking about it now for the next phases. But the packages, I love them. They're easy to handle. You know what stock you've got. It's just really easy. Yeah, they're only 4.5 meter holes, and we've put the B&Q screw fix drain pipe, 2.4 meters long. Go and buy some, get it in the van, cut it up into 0.5 meter lengths, and shove it in the holes to protect them. Because you can see how shitty it is down there. You'd lose a hole, no problem. Yeah. So you needed them collar pipes in. John Percival on that photo there. And then that's us unloading, placing at each hole what's to go in it. Right, go. Get them in. My other battle here with a lot of people was what to use as stemming. I'm used to quarrying, chippings, gravel. I had to go through quite a lot of arguing to keep my way. So we used it, and it's brought, you can see it there, and we brought it in these sandbags. So all these sandbags have got gravel in them, ready to pour into the top. All the underground guys, what the hell's this? It's chippings, oh my God, you're going to fire it all everywhere and all sorts. So I stuck to my guns, and that's what we used. Products, Senatel Power Frag, Orica, 53 mil. Probably a little bit smaller than what we might use in the quarries, like you up to the 70s and 85s, aren't you? It's a funny size product. 32 mil would be more, or a 25 mil diameter would be more like for underground. Because we were drilling the 64 mil hole, we could pack it with this stuff, yeah. Power split for around the contour, around the edge. Yeah, I like that stuff because we would pre-cut it to 3 meter lengths, 3.5 meter lengths, fire it in the holes, dead easy. Icon 3s. We were going to use shock tubes from EPC, but the quarry mine manager who took over when Anglo American bought the project 2020, he'd been in Australia using Orica and Icons, and he immediately said switch out for the Icons. No problem, whatever. I said, don't matter to me, we'll use whatever you want. I know it's debt sensitive, the power frag, but we'd already bought 3,500 of these cast boosters off EPC, and they weren't going out of date, so we used them up. Yeah. And then some mini boosters. We had a mix of reasons for them. We've used them on the power splits. The late Malcolm Ingray, actually, he said to us, just please sellotape one of these to the power split. But again, even though it's debt sensitive. So that was sort of Orica's product range. The only difference, we have had some 32 mil, quite a lot of 32 mil power frag for the tunnelling bit, which I'll show you in a minute. And we've had some 10 meter Icons as well, which are really handy. Because when we do the tunnelling and the holes are up at 3.5 meters and they're 3 meters deep, you've now got a nice long lead coming down to this height, ready for logging them on. So we've had some Brexco products as well, 55mm and 32mm. It's similar to the Power Frag, similar spec sheet. The only problem with this stuff is it's 700mm long, and it's just a little bit. It can give me a bit of a pain to work with when you're trying to put it in the holes. Yeah, I like the Power Frag's 1/2 metre long. You know as well, when you're drilling holes, everyone likes to keep within these 1/2 metre. So it's just easier with 1/2 metre for your calculations. So sometimes we're having to cut that in half, which can get messy, especially with the open end. And yeah, because the other thing is they're just a bit wider, 55mm versus a 53mm Power Frag. You won't think it's much, but when you're trying to get it in a rough hole and it just gets stuck and ripped, and you know what it's like. Void holes. So although they don't get an explosive charge as such, they won't charge them. What we did do was put cast boosters at the bottom in the water. They fired first, and then the round started to fire. The idea was we thought, well, let's clear the water out. And then they are void. Did it ever work? We don't know. The shaft got sunk, so it must have done something. But the Canadians had never seen it before. They'd never done it. And they thought, well, that's actually a good idea. Never really thought of it. So using the icons, great. Just fire them on a 0. And then I think I used to fire the first hole on 1000. So it gave a whole second to atomize that water, shoot it up, and then start the round. The yellow holes, if you will, cut, or the red and yellow, pretty much cast booster, icon, 4, 5, 6 sticks of Power Frag. But when you're charging your quarries, have a look at that diet. Would you do that in a 3.5 metre hole in a quarry? No. Well, I wouldn't have done. It's like the other way around, isn't it? We'd normally have like a small charge in, like toe holes, if you will. You'd put like a little charge in the bottom and it'd have 2.5 metres of stemming. Here, it's the other way around. And I'm like, well, that's wasted. It's got to be wasting. I'm used to doing it in a quarry and seeing the results. But you lot, the underground guys, are coming out of the mine, the tunnel, the shaft, then firing it. So they're not actually seeing it. So if you can't see it, all they do is just overcharge everything. I mean, it's overcharged, which I'll prove in a minute. So yeah, 60 to 75% charge, 25 to 40% chipping, stemming. Perimeter holes, power split. We used to sort of bunch 3 of them up at the bottom just to give it that little kick at the toe. Rather than sellotaping a Power Frag or anything to it, we just fold over the power split. Mini booster, recycled explosive boxes rolled up into little cardboard tubes, and then pour the chippings on top so that the chippings don't all come down the side. Again, it worked. I do have a photo. Yeah, similar ratio. We used to bring them up a bit higher, but again, 1/2 metre long. Dead easy. 4.5 metre holes, 1/2 metre long power splits. So I used to just cut them to where I wanted them. You didn't have, you know what I mean? So it went up a little bit higher in the hole, but again, the results were good. Well, you can see there. So that's us connecting. But you see the walls. Bearing in mind, this is in like a soft rock. We're only talking 30 megapascals. We're not in a granite. And I was like, when I seen that, I was like, this is brilliant. It's working. I didn't think it would work that well. I thought we might smash past it. But there's a 4.5 metre round there for you. And then the next one's, so that's drill charged, and you can see the icon clips. What else have I got? Oh yeah, so that's me just looking down. You can see the void holes over there on the left. And then this one here. So that's 10 metres diameter, that shaft. Quite big, probably. So it's like the width of this room. The next photo is when we did a blast in the other shaft. It's only 7 metres diameter. Then there's like a little cage that keeps us safe. So it's even smaller. and it looked like that. I'll go on to it in a minute, but Herring Connect wanted us to put 2 detonators in every hole, and we had 109 holes, I think it was, so there's 218 detonators. Like, oh my God. We were just literally keeping a bit of a dry line, a washing line, and just kept clipping on and on and on. Just got, well, it's manageable. We just climb the ladder and come out, but you didn't want it. You wanted minimal people down there at that point, yeah. Because we had one day you trip over these things, they pull in the clip, and then when you come to top, it reads an error. You have to go and re-clip it on. Yeah? You'll know if you've used them. So that was connecting up. So firing time, everybody out the shaft, yeah. Nobody was ever in the shaft. And then we'd sort of, that's that white line that just came on, then that's kind of it's like a fence, a black mesh fence all around, which made life easy for maintaining the danger zone, if you will, maintaining the head count. And we just sort of basically said, right, nobody anywhere near the shaft, the firing points there near them containers, and we had a sentry on a turnstile who wouldn't let anyone in, lock all the other gates. Brilliant. So just on that, when we started, there's 2 of the main directors from Anglo-American. They'd had instances in, let's say, I think one was in Australia and one was in South Africa, where there was, would you believe, somebody was in the shaft when they fired the shot? And they were absolutely adamant that we got that right, because in fact they delayed us for a whole week. They wouldn't let us blast until they knew that we were going to keep that under control with everybody. So we do have ID cards, which are electronic. We've got little brass tallies on our belt, and then we do a full sweep of the area, and it's quite robust, yeah. That's us firing there using the Blaster 3000. That's hardwired in. Yeah, you can see the white cable. So basically that's running all the way across the yard, all the way down the shaft. Well, it switches to an armoured cable, goes all the way down the shaft to the blast. Whereas on the other shafts, we've started to do Wi-Fi firing, which is really good because they're 750 meters down. And we don't have a cable. We never envisaged any blasting in the other shaft, so we don't have a cable ready. So the Wi-Fi firing with the Blaster 3000, absolutely brilliant. We couldn't live without it. There's a little firing point. Oh yeah, so he's on rusty table. So I decided to make a nice little stand for it to go on. The mudstone broke up pretty easy. It's all laminated and bedded sort of horizontally. So when we drilled them 4.5 meter holes, pushed the button, it just pretty much broke it up. You could get away with like a hole that was blocked and things like that. And there's a good picture of the power splits, yeah. It's not pre-split, so we don't fire the power split first and then the middle. I tried it on one day and it went wrong because it didn't work, and I might as well have walked out of the gate because everyone was like really angry with me. It basically, we fired it. So I fired the power split first, then fired the bolt, the main round from the centre out. And when they came to dig it, basically the top 2.5 meters had worked, but it hadn't really added. There must not be enough free faces like in a quarry. Somehow it just doesn't crack. It didn't crack the bottom. And when they were digging, all of a sudden the sides were getting hard. So it hadn't really cracked between. It might work in a hard rock, I don't know. But yeah, it was I don't know what to say. I sort of got told off for it, but then I also reminded them that it was at the time I tried it, it was a good time to try it, because where they wanted to try it, it would have been really bad if we'd have fired that blast where they wanted to try it. the Canadians and that. So in the end, it was all right. So those are two deep shafts. They go off down into the ground down here. This is the MTS shaft. So all them photos you've seen are all to do with that, really. We blasted basically from there, 121 meters down to there. So we blasted all that out. This top section was already dug out with it's like a smaller version of the road header. So then we arrived here, then all of a sudden we have to widen out and then start all this tunnel work. Can't just think of the date we sort of arrived at that 321 meter mark, but anyway, that is what we're on with now. So if I just go back up, you see where it bellies out at 40 odd degrees, that's that grey bit, and then we've to do all these tunnels, and that's what we're calling phase 1 at the moment. Phase 2 you'll see in a minute. Right. So to get that wedge out, that where it says A, then 45s, we did it in 4 blasts. Ralph, 4. So 1, 2, 3, 4 is the white box. The next one down. By far, it's just sorry, yeah, just go up one. So see that where it says hitch. This was the hitch. We just drilled it on a very slight angle out. But then we had to, you can see all the supports we've put in on that. It was, the reason for all them supports was it was left exposed for quite a long time. So we put extra support in, not just the mesh and the bolts, but we put them straps on. But look how crowded it's getting. We're still only 10 meters diameter here. We're not really opened up. It's 4 drill rigs. It's quite, there's probably like 8 people on that foot, like in that shaft at the moment. And then you start getting this sort of thing, like where the driller's having to sit on the floor because he's controlled. The control box don't move, if you will. So it's fixed on the mast. So those 4 blasts looked like this on Shot Plus. And by far, like I said, the third one was the most complicated one. These are the photos of them drilling it. Yeah. So you can see there, we're literally touching the shotcrete to get as the maximum, as many holes and as much volume as we can get out of that blast. Controls are now up here. He's trying to, the wall's riding up and I'm wanting him to drill up here. So he's put the drill bit on and controls are now, so a lot of challenges. That drill is maxed out. It will not go any further, and it's pretty much right up against the shotcrete. But all the madness and all the hard work of trying to run around, organise, so I'm running around on that bench, telling them angles and depths, and they're all screaming at me, 4 drillers. It only takes them a few minutes to drill a hole, and then I'm being shouted at across the other side with my clipboard. The hard work paid off, which you'll see in the next photo. We've got the blast out, and that's the Galloway. It looks like a rocket, doesn't it? That's the Galloway. It's just a good photo. That you can see we've lowered it down, and then that's probably the best photo that's been taken. Unfortunately, not by me. All the others are from me. You see the angles and stuff that's at. Some amount of volume. One of them blasts, we used 1,900 kilos. It's not a lot in the quarry terms, but that for us was huge. We were using maximum 750 kilos in a blast, maybe around the 500 to 600 mark normally. Some of these were like nearly 2 tons, so that's a lot for us. So now we got down and then we had to start tunneling. So the yellow mesh at the very end, we had to start tunneling that way. And there's one behind me, like on the photo there. Basically tunnel in B and B, if you will, that, the north one and the south one. By January, when I did this presentation at Wetherby, we'd took out sort of that area. And as of say today, we've now, in the past, for sort of 4 months, we've sort of taken out them patches. And what you see there, most of it, let's call it 75% of that, has been done with hand drills, would you believe? Not good on halves at all, we know that, but ultimately we couldn't get a jumbo in yet. We've got one in now, but yeah, hand drills, old school. And to be fair, they're really good. You know what I mean? That's actually the first blast in the north side. We peckered in a bit, I think, and then that was our first one. And that was it. So that's before the blast, after the blast. And then I've come down then and took the photo looking up. So a good fragmentation. Yeah. You think, oh yeah, so that we use power split again in the roof. You can see the all barrels. Bit skew width, yeah, not very. Again, with hand drills, they've got to be. A lot of them were new to hand drilling, yeah. The Canadians had done a lot of it, but the Brits, they hadn't really done any. Some of the coal miners. So now that photo was taken not that long ago, a couple of weeks ago maybe. That's me looking south. So we've took all that out with hand drills. 3 metre blasts. Yeah. And then, can you see the ventilation going off to the left? That's us started one of them other headings that you saw that are coloured in green. And then I think this photo, I literally took that Friday night. So you can see the back wall on that one, where the lads are right at the very back. But this one, it looks similar, but it's actually obviously a bit further. And what we've been doing, rotating the blast. So we've roadway 3 in there, we'll blast that on like a Monday, say. Tuesday we're at roadway 5. Wednesday we're in the other one. And they're all at different stages. They're all on the go at once. We're back on 24 hours now, so it's quite mental for me. There's a lot of I'm wanting to know how many detonators did you use, lads? How much explosives? And I'm getting texts at the weekend coming in, and I'm trying to keep on top of the paperwork at the weekends, typing in the figures. 2 Toros, we bought them off QME in Ireland. Bear in mind that they've come through them holes. We've took them apart, sent them down, and built them back up. I mean, you wouldn't. They're bigger than a 1.9 metre. You know, you wouldn't lift that in one go, would you? The next one's better. So we bought that off QME Mining. Let's get rid of the hand drills a bit. Let's get the jumbo in. One arm, one boom. But that's not going to fit. There it is, totally in pieces, coming down. You literally couldn't stripping any more off. There'd be nothing left of it, would there? So that's it. That was just 3 months ago, maybe. That's it landed. Fitters straight on it, trying to build it up a bit more, and then that's it drilling. I think we've done quite a lot of blasts with this now. I was just looking through it before. We've probably done like, I don't know, 10 or 15 blasts with this jumbo now. So it's quite. It's good, like. Yeah, another picture there of him drilling the reams or the voids, and you can see the power split holes across the top again. We okay for time at the minute? Yeah. So what I showed you before, phase 1, was like that 3D model with. They were like little tunnels. We've to take the floor down again 3 meters. And when we do that, that phase one's over, and we're potentially shutting down that shaft. And the Worley, who are the main contractors, want to fit it out with a new mucking system, conveyors and buckets and all sorts. So when that's done, that is what phase two looks like. And just to give you a little bit of comparison, so phase one, we're going to be running on that till at least October, November, right? So all them little tunnels, we have to keep going till about October, November, when we finish them. That's just that bit there. That is absolutely monstrous. The blue tunnel alone is something like 500 meters long, and it's either 10 or 12 meters by 12 meters. And because they won't allow us to blast, they won't allow us to take out more than 6 meters wide in a blast, 3 meters deep, and 4.5 meters high. What it means is we have to tunnel that 4 times, unless we can get a road header to do it for us without the blasting. But like I've said to them, you're never going to get all of that out with road headers. There's going to be blasting, so there's a lot of work there. That's the TBM coming through here, by the way. That's its dead end there. So from Middlesbrough comes to there. And the other thing on there, you'll note, well, 1, 2, 3 shafts. There's another one. There's potential for blasting a 4th shaft to a mile deep. I don't know why they're not wanting to use the S. Well, I do know. I'll show you in a minute, but that's a lot. A lot of blasting. You know what I mean? A mile deep. Right. So that's where we're going with, if you will, the MTS shaft. So I'll just move on. The other shafts, right? The deep ones. They've got these water cubbies, 4 of them in each shaft, every 350 meters roughly. They tried to pecker them out. So they managed to get the top section out, but it took them ages. So then they said, can you come and blast the floor? So that's what the water cubby will look like. They said, can you come and blast the floor out? Yeah, no problem. So they drilled holes. You see them all lined up, the pipes, 32 mil power frag. Blast it out, brilliant. But it was a world's first, because I haven't put a picture on, should have put it else. Yeah. Those SBRs with the head is sat just 3 meters higher than sort of where I am now, up the shaft. They've never blasted underneath an SBR before. It's the world's first. This blast was the world's first. So that's me on the SBR. That's how high it is, looking at the blast, and then that's after it. It just came rocketing out. In fact, it was so good, you could walk in to there. You went up and over, like, if you will, into the power trough, and you were walking on the hard floor. It shunted the blast so much, you were now on the fresh floor. Couldn't believe it.
And you got 700 meters of shaft below you.
No, so they stopped at that point and let us get in. So they stop at each time they get to the white rectangle, if you will. So stop, take out the cubby, then carry on sinking. So at the moment, we've done, I think we've done 2, like 1 on each of there, and then 1 of these, you know. So we've done 3 out of the 8. So the second time round, they said, right, we're not going to pack it out. It takes too long. Just go and blast it. So that's us. That's us sunk down to, that's at 300 and something meters. And then we've to take out 14 meters, 4.5 by 4 point whatever. So that's us, that's hand drilled, ready to go. Oh, that's a good photo. So that's how high this, bearing in mind, this machine, you're talking, I don't know, it's £20 million to buy. You damage it, the whole that shaft stops. That's multi-million pounds. And they're like, well, will you damage it, Neil? I'm like, well, I don't know. Will we? Well, you know, you want it blasting out, you want it smashing up, but you don't want to damage that machine that's literally parked above my head. You can see, I've just turned my camera up and took the picture. Like, oh my God. So we knew from the other blast, the floor one, which we had, was like a mini quarry basically, that had a bit of play in it. So we had a bit of room. This one was fresh, firing straight out into the shaft. Anyway, fired it, no problem. Gets better than that though. That's the kind of result we were getting. Bit raggedy on the edges, but I think I got, yeah, so the power split again. Yeah. Anyway, we carried on, 5 blasts in, 14 meters deep. Everyone's happy. Some power split photos, basically. But next problem. This layer here at 800 meters to 1,000 meters. That's 200 meters thick. That's the same thickness that we blasted at the MTS shaft. It's hard sandstone. They don't think the SBR can get through it. Neil, can you blast it? I don't know. Where's the SBR going to be parked? Oh, 3 meters above the blast. Right. Great. What you know, talk about how many balls can you want it blasted, you want it smashing up, because this thing grinds the rock and hoovers it up. So they want a blast that they can just hoover up. Well, I'm like, well, you've got to overcharge it like mad because you want tiny pieces. But your machine's parked right there. So, little competition. Has anyone ever seen that diagram? Orica boys.
It's skill very.
Ah, right, okay. I'll ask you later on. I used it obviously. This was us. We're not at 800 meters, we're not at the 200 meter thick sandstone, but what we're at is a thin layer of it. They said to us at about 510 meters, there's a 2 meter band of this hard stuff. Let's have a trial in it. So this was me being asked to blast with the bloody thing 3 meters up. So that's me coming in on the morning. The holes have been drilled. You see the pipes in them. So I'm going to go and get the explosives and we'll go down. Loading up, 32mm power frag, 2 dets in a hole. If you remember the diagram before, with all the icons coming up, that's this one. I was that OCD with the charges. These holes were only 1.2 meters deep for this trial blast. We were down. I made a device, a little wooden thing, and I was cutting the pills into quarters. We're down to grams of explosives. You know, we're talking like, well, measure a hole, right? That'll have 3/4 of a pill. They're only 400 grams each. So it's 300 grams in a hole. But the problem is the SBR above my head. You can't damage that SBR. Just do not damage it. That's us wired it up. And that's us fired it. So I do have a video, not on here. I'd have to play it off my memory stick. We don't have a burn cut in it. I says to him, right, quarry, we're going down the quarry route now. We're having small charges, big stemming, no burn cuts, because we wouldn't do it in toe holes in the quarry. You just mark the pattern out and fire it. Quick timing, 17 millisecond connectors, whatever you want. I says, that's the process we're going down with this blast. I'm not having the Canadians interfering. It's going to be quarry style. And the German who runs the shaft agreed totally. He says, you do what you think. And even on the way, when I was driving in, I remember I changed my mind on the amount of charges, these quarters and stuff. So I was even changing my mind on the morning going in. Anyway, success. A second, world's first. Now we've blasted directly underneath the SBR, damaging nothing. Maybe a sensor or something, because they leave the electricity on, so he gets a bit of a shock wave, right? So when you see the video, well, I'd have to put it in, but it's dead quick. It just pop. I says to him, listen, in the quarry, you just pop it up, it comes back down. That's it. Down, done. And that's how it runs. You don't see much because the water splashes up at the camera, like. But yeah, good result. So that was just showing that again. How we do for time?
6 minutes.
The rest of it is more to do with the magazines and other bits and pieces if you want to see it.
Take it through to just after 2:15.
Yeah, okay. So magazine setup. All we're missing is a few SAS guys on each corner. We've got 2 magazines tucked inside each wing of the inside the HESCO military bunding. We're allowed 1,000 kilos in each. Detonators actually are in that little where the red line is on the bottom one. The detonators are in a little cupboard on the side. That's where the MTS shaft is. I know we're working on the others, but give you an idea. It's only like a 500 meter drive up from the magazines to the shaft area. That was so the Brexco magazine at the back. This container here was like somewhere where we could do track and trace, cutting power split, preparing the gear. Yeah. Products, we've got both there, got some Brexco stuff, Austin. Nice and tidy, yeah. Detonators in the little cupboard, Icon 3s. And that's a delivery coming in, so we just unload it onto that bench, zap it, and then put it through into the magazine. Yeah, we're using the X-Tray. I think you've got one now, Johnny, haven't you?
Yeah.
It's, to be fair, it's actually quite good. It's the newer version of that now. We did have that one. We're on the newer one. It is quite good. Detonators, we take them out of the Icon boxes, put them into these. These are really good. You've seen them before with the lasers and all that. They do keep, because you can imagine you're climbing in and out of them buckets. It's shitty down there. They keep the depths in. So you open it up, grab one, and almost like the lid would close, and then you charge that hole and you come back and they're all clean in that. If you take them in the cardboard, you saw the floors, it's just all wet, and there you go. That's an old photo now with where the depths, that's how we transported them, like tucked on the back. We switched now to Land Rovers. That was a Toyota Hilux. Casper boosters, we would do the same, put them in orange cases, take them with us, like that. Whereas the Power Frag and Emulex, we'd just leave it in the boxes because you tended to use most of it. So if the boxes got turned to mush, it didn't matter. But certainly the cast boosters and depths were kept in the Peli cases. So those were the 2 vehicles we used to have. They went off hire, and now that photo was taken just the other day. We've got these 2 Land Rovers, and we put buggy whips on. Yeah, so that's the route. It's dead easy. It's not very far. Last specs. I tried to bring in all the best stuff from the quarries. Yeah, we know that the quarries regs, you've got the blast specification. Underground world doesn't know necessary. It's not necessary for any of it. So I brought in all the best practices I could, showing charges and all sorts. It kind of, what's the word? It wasn't a waste of time, but it was. They're so used to not having it that they didn't really see the point in having it. So ultimately now I've cut back on the amount of stuff I produce. We used to produce full-on packs like you would in the quarries. Yeah. Now I don't even print them. They're all on PDF on the laptop. Timing plans, hole charging depths, what's gone in each hole, danger zone plan. That's kind of what it looks like now. I've kind of condensed it all into a 1 A3 sheet, which tells you almost everything you need to know. the roadway that it's in, everything. I love my Excel sheets, as you know. Danger zone checklist, like I said, robust. Anglo wanted them to be robust, so we have these checklists. Stock record sheet. And training, OCD to the max. I've got folders with labels, and we're trying to get through everyone through the underground blasting on the MPQC side. With those at that time, those were the three lads that these two were shot firers, and this one was down. He got the storekeeper endorsement on the back. So that's it, and that's a question there which Stephen's already answered. It was to win a bag.
Stones.
The question was, what was the diagram? And you got it right. Scale depth of burial. I've never seen it before till I went to Woodsmith, and I used it on that blast underneath the SBR. Yeah, it takes into account your stemming heights, your hole diameters, and a little bit of charge. When you look deep into the calculation, once the charge goes past a certain point, it doesn't really matter what you put in the hole. So it's quite good. And so you've won a bag. There is a second bag to win. If anyone can answer, not the Orica boys, what was the diameter of the power frag, the biggest stuff we were using?
55. 53 or 55.
53. You can win. There's some freebies actually in this bag. We'll put them out, and then you can have a bag.
I do.
That's it.
That was a fantastic job. That was really interesting. Yeah, something different to the usual quarry stuff they were involved in. So, some questions. I've got a few questions. You also had water in the shafts. So, how bad was the water problems in getting it extracted back out of the shaft again?
So, what we would do, the buckets where the muck gets put in, we'd lower one of them empty, put a pump into like a low spot, and then just pump it into the bucket, send the bucket up and tip it. So it sounds a bit sort of pieced together, but that's the only. There was no way of pumping it all the way up 300 meters in the pipe. So we literally pumped it into a bucket, and when it was full, sent it up.
How often that take place? In like twice a day, 3 times a day?
So when they were drilling, if you had 4 rigs going, that's a lot of water now. You were swimming in water. I couldn't tell you. No. They maybe in one drilling cycle, they maybe do 4 buckets worth or something. The buckets are quite tall. They're like 2 and a bit meters tall.
So, in terms of your emergency rescue procedures, how often do you practice them? How do you get people out from the shaft as a problem?
Yeah, when do we do them, Charlie? We've had some done, haven't we? We've done quite a few exercises where we've laid somebody in the corner of the shaft, and then the mines rescue team have got to go in while they're drilling. Like, we don't stop the shaft sinking operation, and they've got to go and find him and rescue him. They're probably done once a year, maybe.
Annually we do one.
Yeah. We've done different scenarios as well, out of the shaft at the magazines and in the shaft. So there's different casualties. So sometimes they have to literally put them on a stretcher and lift them vertically, put them in the bucket to go out, because there's not room to lie horizontally.
Yeah.
So anybody going extracting, it's got to go vertically. So they've got to be strapped in pretty well.
Okay, thank you.
Yeah, there's a 20-foot, there's a team on site that like mines rescue. So any incidents they're on it straight away.
So they're always based on site, are they?
They're on site all the time. Yeah.
Any other questions?
Yeah. Quick one, when you were doing the development, you said that you were limited to dimensions.
Yeah.
And we had type left. Why was that?
Oh, yeah, so if you will, the geotechnical engineers for the project have done a design on that rock type, and they've determined that we can't take more than those dimensions. It gets awfully complicated because some of the tunnels we're blasting are 8 meters wide. We're only allowed to take 6 of it. We have to go and take the other 2. So we have to tunnel twice. But it's as simple as that. Safety over the grounds, how much we're exposing in that rock type.
And you're doing ground support every round.
Every round. Hand drilling the bolts in with no bolting machine, so they're all hand drilled in, and then the mesh, and then the shotcrete comes as well.
What's the cycle time on the 10 meter shaft?
On the 10-meter shaft, right? So the best we ever got was 3 in 7 days in the week. We got 3 blasts at 4.5 meters each, but only 2 of them were sort of mucked out and 1 concrete. So the 3rd blast was still in the ground, because what they tended to do was dig a bit out and then put the bolts around the walls, then dig a bit more out. So that was the best, it was just over 1 meter a day advance. That was the best we got. Whereas a lot of people wanted 3 meters a day. Just it wasn't possible.
You cut your program by
Yeah. So it's slightly different now with the tunnel work, because we're sort of blasting 3 meters and then they're mucking it out with them toros, and then a little excavator's feeding the buckets. So there's a lot happening at once. We might be mucking one heading while drilling another now. So it's probably quite efficient, if that makes sense.
Where does your waste go, Neil? Is that a sellable product?
A lot of it's on site, actually. So you know the mine of the future where it's hidden. A lot of it's been forming the buns, yeah. But it's going to have to go somewhere, because there's no way. That phase 2 diagram with all that spaghetti of tunnel, there's no room for that. No chance. So that's going to have to go off-site somewhere.
What does a ton of potash go for? Because I can't understand the economics of the cost that you must go through to
How much is it at the moment, Charlie?
About 500. But it's the like the polyhalite, all your costs are in mining it. Once you've mined it and got it out, you just have to crush and screen it. And then that's the way, like the process for the potash is, you've got the photo for the getting into the nice sphere for the farmers, whereas the polyhalite's a lot easier. Once you've mined it, that's your biggest cost. You just process it and go.
And is that future going mining done by road headers rather than blasting?
Yeah, it will be. Yeah, it'll all be run from like a central location at Wilton, at Middlesbrough. So a lot of it will be automated. That's what we're going for. There will be saving in the ground, but most of it will be run from automated roaders. Yeah, probably scope for some stoping down in the same that we're in, but 10 years off that, maybe something like that.
I'm assuming your market must be like UK, if not European wide for your polyhalite.
Yes.
So what was the point of taking small trucks off the road going from Whitby to Middlesbrough, whereas the market is European?
Well, it's not really in the UK. It is in the UK, but it's real good at like green leaf and like tea, tomatoes, that kind of thing. So there's a lot close to Brazil. It goes worldwide, really. So
Yeah, so I'm just saying, like, what was the point in that massive big tunnel from Middlesbrough?
it's a triangle.
Yeah, sorry. So the setup at Middlesbrough is a bit like Glensander, where you have it's loaded onto ships. That I didn't really show that, but it's loaded onto ships, and I think Qatar have signed up to so much, and like you said, Brazil. And
We've got the berth that we've got at Teesside in Teesport is like it's before there's a little tunnel that goes under the Tees where all the pipework comes in. And that's way before that, so we'll be able to get a bigger diameter of shipping into that area. But it's straight to the port, really. It's straight from the mine up to 360. There'll be a big bunker there that will hold sort of 24 hours worth of mining. So if there ever was a problem in the tunnel, then we'd have 24 hours to sort it out. And then that belt would be going all the way through to Teesside, to straight to Teesside, 3 or 4 lamps there, pushing it, screening it, put it into the sphere, and then away on the ships, wherever it was. So,
Where does all your tunnel boring? Spoil.
Don't know.
Teesside.
Strabag's problem.
Well, the where the blast furnace was at Redcar, it's like a massive site. And a lot of it's going on there. A lot of it's being used for the redevelopment work that's happening in there. Yeah, not really.
Okay, it's almost dinner time.
Yeah,
Take me one more
So
minute.
I've got a quick one. Can you expand a bit more on why you're doing this, why it's so important to have the smooth wall and what you're doing for, I know personally what it is you're doing, but I think it's got a good point to say it, or the saving that you can do when you have it.
Yeah, so
You get it.
less overbreak, which means less concrete. As simple as that, isn't it? You
Turnaround.
don't, yeah, it's quicker turnarounds. You don't use the power split. You might end up with some great big chunks taken out of the wall, and then that's more concrete, more time. Yeah. Sorry, Charlie works with Anglo American, and Charlie's the explosives lead for Anglo American. So we work basically every day together on doing all this kind of stuff. I was meant to introduce him at the start, but that's how Charlie knows more about that side of things, the Anglo side and the tunnel and things like that.
I just carry nail back.
Yeah. That's, you carry that.
One last question, Neil. Are those drill rigs automated? The shaft sinking drill rigs, there's 4 people.
No, literally all manual on the hands, just no.
So you can't feed in a drill pattern on surface and
No.
as the
For the 200-meter thick sandstone in the deep shafts, they're looking at a automated one. I'm yet to see it in action. They better hurry up because they'll be wanting this blasting done in October onwards in that sandstone. Otherwise, we're on hand drills.
So, thank you for the excellent presentation. That was absolutely fantastic. And thanks for coming up to see us. And thanks to all the branch for coming out to see us again. And thanks for continued support. I hope to see you again next year. The technical things, if there's anything you want to hear or see, let us know. We'll try and get it sorted out for the next session. And after dinner, those are going to the committee, please meet us for a quick meeting. Thank you again, Neil. Thank you.